Hi everyone, I'm teacher Susan. This video is about Form 4 Maths Chapter 2 Number Bases, Lesson number 1. In this lessons, right, we will see numbers in terms of numerals, place value, digit values, and numbers values. Okay, so all this while when we do counting, we do this counting, start from 0, then we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, we know that we need to change these numbers, okay, into 2 digits, become 10. Okay, after 9, it will become 10. After 10 is 11, 12, 13, and so on, right? So these digits, these numbers, they are in a system of 10. We call them the base 10 system or a base 10 system, yeah, base 10 system, or another one is decimal system, okay, decimal system. Okay, decimal system consists of 10 digits. After 9, you will see that the number become 2 digits. So 0 until 9, we call them digits. They can be referring to digits. Or when it comes to counting, they are numbers. Okay, they are numbers as well. So please differentiate the differences between digits and numbers. So 0 until 9, 0, 1, 2, 3, 4, 5, 6 until 9, they are digits. But when it comes to counting system, okay, when you do counting, they are considered as number as well. Okay, they are considered as numbers. Okay, after 9, we know that the following numbers is 10. So 10 is a number. 10 is a number. Okay, this number consists 2 digits. Okay, this number has 2 digits, digit 1 and digit 0. Okay, after 9, you will see the number, we write it in 2 digits. Okay, this is number. This number has 2 digits. Okay, it has 2 digits. So this is the difference between digit and numbers. Okay, digit for base 10 has it consists of 10 digits, okay, and a singular symbol. Okay, digits is one symbol to represent it. And then after 9, okay, you will see 10, 11. If you want to express there are 10 stuff that, okay, 10 carrots or 10 balls that, okay, you will use 1 0 to represent it. So that is about number. Okay, and after that, we will see place value, digit value, and number values. Okay, still, we will use another example, 13, for example. 13, it is a number. Okay, 13 is a number, and then it has 2 digits, digit 1 and digit 3. Okay, digit 1 and digit 3. So these are the digits. To combine, become 13. Okay. Digit 1 and digit 3, they have different place value. Okay, what are the place values we're talking about? The place value of 3, we call it ones. The place value of 1, we call it tens. So this wording, these words, we describe the place value of the digits. Then the next one we're talking about here is the digit value. The digit value. So what is the digit value here? 3 means just 3. 3 means that you will have, for example, 3 balls add together to become 3 balls, right? So one symbol is represent a balls. Okay, but what does it mean? 1 means 10. It means that there are 10 balls add together. Then you have 10 balls. Okay, we will write words 10s. 10 balls. So this 10 and 3, they are digit value. Okay, they are digit value. So altogether, there will be 13, and 13, it is the number value. The number value in decimal system. Okay. So this is the differences between place value, digit value, and number value. Okay, just now we were discussing about decimal system, which is base 10. Okay, look at this chart. This chart you can find it at textbook page 34. Page 34, you can see this table. Okay, you can see base 10 is the last one and is formed by 10 digits 0 until 9. Okay, you don't see 10 here. Okay, why? Because 10, it consists 2 digits already. Okay, the same idea if you see base 2, right? Base 2 consists only 2 digits, not including 2. And base 3 has 3 digits, but not including 3, the digit of 3. Base 4 is 0, 1, 2, 3, don't have 4. Okay, base 5 is 0, 1, 2, 3, 4, don't have 5, and so on. Okay, base 2 has 2 digits only, okay, but not including digit 2. So all the digits when we do consideration, right, is start from 0. Then the next one is 1. Okay, and then the next one is 2. So let's say base 7. Base 7, you will see 7 digits, but 7 is not in the digit system, like 0 until 6. Then what is, for example, here we come back to base 2. What if you want to express 2? What you want to express the number value as 2 in base 2? So number value, I mean the number that you want to represent in base 2, right? You will call next one is 10. 10 base 2. We'll write like that. So 10 base 2, it is the number value is 2 in decimals. In decimals, it's called 2. 2 in base 2, it become 10 already. Then how about 3? 3 will become 11 base 2. So this is about the binary system. Okay, 3 in base 2, it is 11, and then we write a lowercase 2 here. Okay, so this is when we do counting. So again, okay, if it's base 2, we'll start counting from 0, 1, then the next one is 10, then the next one is 11, the next one will become 100. So in base 2 number system, right, you don't see the digit 2, you only see 0 and 1. Likewise, like base 10. In base 10, we don't have a single symbol to represent 10 in this Arabic system. Okay, at most we have 9. Okay, we have 9. But in other languages, we do have symbol to represent 10. For example, in Mandarin, 10 is this one. Okay, 10. 10 is only one single digit to represent tens. For example, yeah. Okay, let's move on to example 1. So we try to give some examples for each of the number base. Okay, for each of number base. Okay, just now when we discussed about base 2, okay, we have given one of the example. Okay, same like in textbook. This is on textbook page 35. Okay, one of the example is 10 base 2. Okay, this one we read it as 10 base 2. So 10 base 2. Okay, another example given by the textbook is 10012. Okay, you don't see, okay, exclude this lowercase 2, right? The number you don't see digits which is more than 2. Okay, the digits that form by the numbers is only 1 and 0. The digits to form numbers only 1 and 0. You don't see 2 there. Okay, for base 3, the textbook given 21 and then base 3. So you see the digit can be 2 now, but you don't see 3. Okay, the 3 is the lower case. And then another example, 1201 base 3. Okay, you can see 1201, you don't see 3, but the digit can be formed by 0, 1, 2. Okay, for 423 base 4. Okay, 213 base 4. Okay, you don't see 4 there, yeah? So base 5, you can 41 base 5. Okay, it can be 342 base 5. You can see 0, 1, 2, 3 up to 4, but you don't see 5. Base 6 is like 5 base 6. and then 4,510 base 6. So the digit can be formed by 0, 1, 2 up to 5, but you don't see 6 here. Okay, if 7, okay, 64 base 7, 463 base 7, okay, and so on. Okay, you can check from the textbook. Okay, example 2 is on page 36. On page 36, state the place value of each of the digits in the numbers below. Before we discuss these two examples, right? Let's use decimal system to check our understanding. Okay, given a number here. Okay, for decimals numbers, right? We don't write the lowercase. Okay, you can see when we have the lowercase means that this lowercase represent the base. Okay, what type of number base? The number base. Okay, like A 6,231 is base 8. Then another one, or B, question B 11101, this is base 2. But when it comes to decimals, right? Decimals we don't write lowercase. Decimal means a base 10 system. Base 10 system, we don't have to write the lowercase. Okay, we take an example base 10 system. Let's say we take a 295. 295, we don't write the base 10, yeah. And then the question state place value of each of the digits. You can see this decimals number has 3 digits here. Has 3 digits. We know that the last one is tens. And the last one is ones. Okay, it's ones. And then 9 is tens. And then 2 is hundreds. So these are the called place value. Okay, when we express place value, this is in terms of words, but when we express the place value in terms of the numbers in numbers, so this means 10 to the power of 0. Once it's 10 to the power of 0, because 10 to the power of 0, what do you get? You will get 1. Okay, then tens, right? Tens is 10 to the power of 1. Okay, because 10 to the power of 1 is 10. 100 is 10 to the power of 2, which is 100. Okay, when we look at this one, the power, it will start from 0, 1, 2. So this is for decimals base 10 system. Okay, the lowest place value is ones, and then tens, and then hundreds. Then how about base 10, base 8? Question A is base 8. So base 8, we don't call them the ones, tens, hundreds, because when we say ones means that it means 1. When we say tens means that 1, 0, tens. Okay, hundreds means 100. The value itself is 100. But when it comes to base 10 or other bases, right, we don't call the place value as in words, okay, because it does not represent the words. However, we will express them in terms of this power form. Okay, it will in terms of this power. Okay, let's see. Question A, 6231 base 8. So there are 4 digits here. We look at digit 1, this place value. This place value, if it's base 10, right, we use 10 to the power of 0. If it's base 8, we use 8 to the power of 0. Okay, 3 is 8 to the power of 1. 2, 8 to the power of 2. 6 is 8 to the power of 3. Okay, start from the last digit. The place value is 8 to the power of 0. Then 3, the place value is 8 to the power of 1. Okay, 2, it is 8 to the power of 2. 6 is 8 to the power of 3. If we really have to express in words, then the last one we still call it ones. Okay, because 8 to the power of 0, it is 1. Then 8 to the power of 1, right? We don't call it tens already because when you calculate, it is not equal to tens. Instead, we will call it eights. Yeah, 8 to the power of 1 is 8. Then 8 to the power of 2 is 64. 8 to the power of 2 is 64. So then how do we call this one then? In words, we'll call it 64. 64. Sounds strange, yeah? So likewise, if 8 to the power of 3, we get 515. Okay, it is 512, sorry. 512. So when we express in words, how? We will just say 512. So if we really have to express in words like decimal system, you can see decimal system, we call it ones, tens, hundreds, because this place represent that value. Therefore, we call it the place value, right? So let's move on to B. B, oh, there's so many 1 here. So 4, 1, and 0, 1 base 2. Okay, there are 6 digits here. When we count, there are 6 digits. Okay, so the first represent, okay, because it's base 2, so it means 2 to the power 0. And this is 0. This place value here is 2 to the power 1. And then 2 to the power 2, 2 to the power of 3, 2 to the power of 4, and 2 to the power of 5. Okay, these are the place value. Okay, to the power of z, the value is 1. To the power 2 is 2. To the power of 2, to the power 1 is 2. To the power 2 is 4. To the power 3 is 8. To the power 4 is 16. To the power 5 is 32. So if you really have to write it in words, we call it ones, we call it twos, we call it fours, eights, and so on. Next example, here, example 3, page 37. State the value of the underlying digits, means that we need to find the digit value for the particular numbers here. Okay, questions A, 3, 4, 1, 8. Okay, 3, 4, 1 base 8. So this 3. Firstly, the place value is 8 to the power of, okay, we start from last one. You can use this one, 0, 1, 2, 1, 0, 1, to start from the last digit, and then you write 0, 1, 2, and so on. So this 3 is placed at 8 to the power of 2. So this is the place value. Okay, the place value. The digit value, you need to multiply this 3 with the place value. Okay, then we have 3 times 64, which is equals to 192. This is, we call it the digit value. Okay, B, 5037 base 9, this 5 here. This 5, okay, again, we start with place value 0, 1, 2, 3. So the place value is 9 to the power 3. If digit value is 5, the digits, multiply its place value. Okay, you may use calculator to do these calculations. You get 3,645. Okay, the next one, C. 3501 base 6. Okay, we look for 5. And again, start from the back, you write 0, 1, 2, 3 on top of the digits. You can write it into pencils. Okay, the place value is 6. Okay, because the basic 6 to the power 2. Then digit value is the digit multiply the place value. Okay, after that you get 180. Okay, D, 2134 base 5. Okay, the last digit here, 4. Okay, start from the last one, 0, 1, 2, 3. Okay, the place value is 5 to the power 0. Digit value, 4 times 5 to the power 0. 5 to the power 0. Anything power 0 is 1. So 4 times 1, 4. Like that. Okay, last example, example 4, page 39. Now we need to calculate the number values, okay, the numbers values. So the numbers values means that we need to add all the place, all the digits and their values together. Okay, question A. Question A. 3, 4, 0 base 5. Okay. 0 is 0 times 5 to the power 0. 4 is 4 times 5 to the power 1. And 3, the digits value is 3 times 5 to the power 2. So for this number, 340 base 5 and its numbers value, we have to add them up together. And this is how we convert other bases into decimal system. So the numbers value actually means that from other base n to base 10. It is a process from base n to base 10. Okay, when we say values, right? When we say values, we always say the values in base 10. Okay, when I say values, yeah. So now after you add it up together, you will get well, you can calculate one by one. First, 3 times 5 square is 75. 4 times 5, 20. 0 times anything, 0. So when we add it up together, you get 95. So this 95 is base 10. You not necessary to write down the 10, but like in textbook, they write down the 10 so that you can understand this 95 is in base 10 value. When we say value, means they are all base 10. Not necessary to write the base 10. Okay. B. 3, 4, 1 base 7. 1 is 1 times 7 to the power 0. 4 means 4 times 7 to the power 1. And 3 is 3 times 7 to the power of 2. And then we add them up together. Okay, 3 times 7 squared, which is 147. 4 times 7 to the power 1 means 28. Okay, 1 times 7 to the power 0. Anything to the power 0 is 1, yeah. So we have 1 times 1, which is 1. So the value is 176. C, 1506 base 8. Okay, is base 8. 6, the digit values is 6 times 8 to the power 0. 0 is 0 times 8 to the power of 1. And 5 is 5 times 8 to the power 2. 1 is 1 times 8 to the power 3. Okay, so we add them up together. 512. 5 times 64, which is 320. 0 times anything is 0. And then 6 times 1 is 6. So add them up together. The number value is 838. Right, that's all. Please try the exercise self-practices 2.1a. And if you are my student at school, I will discuss this self-practice 2.1a with you at our live class. Okay, see you.